So my name is Egor. I'm an Android developer at 1&1. I live in Munich. It's in Germany. So today I'm going to be speaking to you about Gradle quite a lot. So my idea was to, basically I'm doing a lot of Gradle as an Android developer. I believe you too. So there's just lots of tips and tricks and different advices on how to improve Gradle performance. And I just wanted to compile them in a single talk. And I hope even if you're like an expert Gradle user, then even in this case, I guess you will see a couple of slides which can be helpful to you. So let's dive straight in. So you know that Gradle is not a new build tool, obviously, and Gradle is evolving quite fast. So like, just let's recap what happened just this year. So there was a major release of Gradle 3.0. They announced quite a lot of new cool features and, of course, the performance improvements. So one of them is like the faster Gradle daemon. They say it's 75% faster now, and they decided to enable it by default. Shortly afterwards, they announced Gradle 3.1, which also brings some speed ups in how Gradle gets synced with Android Studio, which is also quite cool. Of course, all you have heard about Gradle Script Kotlin project, which is also quite exciting, the possibility to write your Gradle build files in Kotlin. So it's all quite cool. And I think as Gradle users, as Android developers, we have to try to keep up with the speed with all the developments. And this is what we're going to be discussing today. So basically, there are two loosely related chapters today. First of all, some tips on how to optimize the builds, how to achieve more performance, and how to become more productive using Gradle in day-to-day. All right. So let's start with seeing how we can speed up Gradle builds and optimize. So I guess like everybody is more or less familiar with this situation. Somebody more, somebody less. But like when you work, when you do lots of stuff, you tweak UI, you write lots of code, then you hit run, and you kind of wait for minutes, and it can be quite frustrating because you lose the pace and you become basically less productive. Your attention shifts to some other things. So I think it's quite a big goal to achieve as performant builds as you can, and to work towards it. And luckily, at the same time, around the same time when Gradle released version 3.0, they also published this very nice guide. So if you haven't heard of it or haven't read it, I really recommend that you take a look. It's called Improving the Performance of Gradle Builds, and they publish quite a lot of good advices on what to do if your build is slow and how to improve it. It's a quite cool resource, and I'll be quoting some of the parts of it today's talk. So there are a number of quick improvements. This is the things that you can do and see immediate enhancements in your build. So first of all, you should always try to use the latest versions of Gradle. So as I said, like each version comes normally with performance improvements. So if you're using the latest ones, you will actually see that stuff in your builds. So always try to bump to the newest version. I know sometimes it can be painful. So for my team, it took us quite a lot of time and effort to basically jump from Gradle 2 to Gradle 3. But it was quite worth it, so I really recommend that you keep up to speed with the Gradle versions. So like the latest currently is Gradle 3.2.1, and it works quite well with the latest Android stable Gradle plugin. So I really recommend that you try to jump on board with those. So the daemon, as I already said, they're improving the daemon quite fast, and basically what the idea behind it is that to run a Gradle build, you need a JVM instance. And they also have quite a lot of dependencies to run the builds. And imagine like every time you run a build and you have to, so Gradle has to set this instance up, connect all the dependencies. It obviously takes time. The idea behind Daemon is to have this instance that can be reused between the builds. And just save time on instantiating and like loading all that stuff every time. So obviously a thing to use. So as I said, it's enabled. So if you're using Gradle 3, then Daemon is already enabled for you. If you're in Gradle 2, then you can add this configuration line to your Gradle properties to enable the daemon. Still, like there's a case when you probably don't want to use the daemon. It's usually the continuous integration environments, because on those you would usually prefer correctness over performance. So it doesn't really matter if the build is a little bit slow on CI. It's not a huge problem, but still you should try to avoid to share some state between your builds on CI. This is just a best practice to achieve independent builds. So just disable it on your continuous integration servers. The way to do this is either like set the flag to false in the Gradle properties, or you could add the -- no daemon modifier to your builds which run on CI. Also, in case you for some reason want to stop the daemon to basically destroy that instance, then you can use Gradle -- stop. This does the job. Another quick improvement to mention is the parallel execution. So basically, this is the feature that allows Gradle to build the sub-projects in parallel. Of course, they should not depend on each other because this destroys the purpose of it. But in some cases, it can really improve the performance of the overall build. But of course, it depends on your project structure. So for different projects, it can either like gain you some performance or no. So you should definitely try and see how it works in your specific project. So you can enable this feature with the following flag. Also, just put it to Gradle properties. And also, just a short word of caution. In some scenarios, they say this can lead to unexpected results. So there's more detail on the documentation page for parallel execution, so just check it out. There's not too many scenarios that can lead to this kind of artifacts, but still, it's worth taking a look at. So unfortunately, it's kind of all for quick improvements. If you want to dive deeper, then there's a tool for you, basically a couple of tools. So first of all is the profiling mechanism, which is built into Gradle. So you can run any builds and just prepend it with -- profile modifier. And what Gradle will do for you is that it will generate a very good and detailed profile report. You can find it under the build folder. So this contains timings for different build-related activities. So you can see that it has the startup info, dependency resolution, the configuration phase, all the task execution. And actually, like I guess in task execution, they also sort it in the decreasing order of how much time it took. So it's really like you could just take a look and see, okay, I see this task. It takes a long time, so I need to investigate what happens, why it's so slow. Or for example, like the startup, this is what I said, that if you're not using daemon, then probably your startup timing will be a bit higher, and you can see that this is a problem. So it's a really good place to start analyzing your build. There's another feature that I find quite interesting. It's called build scans. So what a build scan is, it's somewhat similar to the profile report. But the difference is that this one is hosted on Gradle servers, so you can access it online, and you can also share the link to it to your collaborators. It's quite easy to set up. There's just a plugin for build scans. You would just apply it. So actually, a note: you should apply it to the build Gradle file in the root of your project, not in the app module or whatever. Then whenever you run a build, you just use scan option on the command line. And at the end of the build, it will just give you this link. So this one, basically, when you click it, when you access it, Gradle will send you an email where they ask you to introduce basically not the email, but I guess like you go to the page, then you introduce your email, and they will send you the actual link to the build report via the email. So it's like a bit of security feature, I guess. So what you see in the end is a very nice report. It's online. So as I said, it looks quite similar to the profile report I showed you earlier. So you could just analyze the timings. It also has some advices on some features that you can enable for your build and so on. So basically lots of stuff to analyze. Of course, as it all goes to the Gradle servers, there's a privacy concern. So you should know like what information travels to the servers, what details they actually log, and they have quite a good documentation about this. So they really like inform you what they track. So if like this is a problem for your company or something, then you will find enough information to decide whether it's worth for you trying this feature out. But like for your own projects, I guess this is quite a nice tool. All right, there is a number of tips and tricks that can also help improve the performance. One of them, it's what's related to the plugins. So I know that like many Android Weekly articles contain some cool Gradle plugins to count your dex method or whatever, like different features. And I'm using those quite a lot, so I'm curious to try what this plugin does. But the idea here is to use them wisely because every plugin will affect the build time, obviously. So if you just tried something and you see that it's cool, but it's not really, doesn't give you any gains, that just remove it because it still affects the build time. So try to not use too many plugins, use just those that you actually need. Yeah, that's the point. There's also a way to basically apply the plugins conditionally. So it's quite easy in Gradle to use the if statement and guard it with some property and what it does. So for example, for dex count, you could just like keep it disabled by default, and whenever you actually need this information, you could just pass a parameter through the command line and enable it just for some certain builds, and it could gain you some performance in some use cases. So for the dependencies, but I guess it goes without saying, because like for Android, there's also a dex method limit, so everybody probably is already careful about unused dependencies. But those still, like if you use quite a lot of them, then just keep in mind that Gradle has to download them and to check if they're up to date, so it also affects the build time. So just remove stuff that you don't really use. Another thing is related to the repositories. So try to not use too many repositories for your dependencies. Sometimes it happens that you also add some dependency, some library to your build, which requires a custom repository. Then you remove the dependency, but you forget to remove the repository. And it still can affect the build time because Gradle will basically just start at the top and try to download dependencies from all repositories top down. And if it doesn't find them like at the first URL, then it will just like quite a lot of miss networking calls, and it's definitely not that good. So ideally, you would just use the smallest subset that you can, and also try to reorder them. So basically, most of your dependencies are probably coming from JSender, so always try to put it on top so that Gradle can actually download most of the stuff from the first repository tries. It's also just a short note on the difference between JSender and Maven Central. So JSender is currently acts as a superset to the Maven Central. So all the stuff that you can find on the Maven Central, you can also find it through JSender. So just prefer JSender whenever you can. Another Android-specific advice is to minimize the number of variants that your build has. So you know there are build types like debug and release, and you also use flavors, and they create a matrix. So each variant is like a node in the matrix. So those are just get multiplied, and this is like the number of variants that you have. But some of those can typically some of those don't make sense. So I can draw an example. Like I have release and debug, and I have two flavors which are QA and live, based on the environments that my app works against, the server environment. And for example, that doesn't make too much sense to me to have like a release version of the QA build, because I will never publish to my customers an app that works against my QA server. So I could just ignore it. So I just instruct Gradle to not consider this variant, and it will just kick it out and will never kind of work with it. So instead of having 4 different variants, you will just have 3. and in some cases, like the difference is bigger. So it's quite a good advice to just kick those out if you don't use them. So another thing I really wanted to mention is that like all the build files, all the Gradle files are actually source files. So you have to treat them the same way you do with Java files. I have seen quite a lot of Gradle files which are just huge, and there's all the stuff just gets bumped in there, and it's like also quite messy. So I had those problems myself. So like best practices of handling a good code base in Java or Kotlin or whatever, they all apply to the Gradle files. So try to keep them clean, and I'll give you some advices on how to achieve this. So for example, one that I really like is the way to better handle your dependencies. So normally you would just like use build Gradle, and you will declare all your dependencies in the dependencies block. This is how it usually works. But what you can do, and I guess this is a nice improvement, is that you can create a separate Gradle file called dependencies Gradle. You can create a couple of maps inside it and just assign them. So just put them into the ext, which is like the extensions area of the project. So first map would be the versions map. So there you just declare the versions of artifacts that you use, and the value would be the version number. Then you declare different maps that actually have the dependency declaration strings, and you can see that they reference the versions from the first map. And in the end, what you will have in your build Gradle is just the reference to those values in those maps. So you could see what we achieve here. Let's just see. So first of all, there's just one declaration of the support library version in my entire project. So it's just there. So this 2500 is just in one place in the project. So if I want to change it, then there's just one place. I go and change it all over the place. Same goes with the dependency declaration. So if you have a multi-project build, then you can declare those dependencies in all your modules, and then you will have problems with also editing it because you edit it in one place and forget to change it in the other place. Here you just have it declared once, and you just reference that stuff in your build Gradle files. So I guess it's quite a good improvement to this process. Yeah. Another thing that's I forgot to mention the apply from directive here. So to achieve it, you basically need to apply this file, basically import it in your build Gradle file. So what apply from is somewhat the same like a Java import. So you just have some configuration in a separate build Gradle file, and you import it to your main build Gradle. So a good example also would be like Jacoco setup. I think at the time when I was integrated it into my project, it's quite verbose for Android. I don't know if it has changed to better, but basically you have to create some custom tasks, I believe. So this has some lines of code. And it makes total sense to just put it in its own file. Let's call it Jacoco Gradle. And in the main build Gradle file, you would just use apply from and import it in there. So you just don't pollute your main build Gradle file with all this configuration. Just store it in a separate file. Okay. Yeah, and of course, to be productive with Gradle, you should use all the tooling that it provides to you. A good example would be the stuff that you can do with the command line. So normally, like if you work on an Android app, you would use Android Studio to run, to basically build your app, to deploy it, and so on. But sometimes it's really useful to switch to command line. So for example, if your build fails, and in Android Studio, it sometimes happens that the output is not very suggesting. So it lacks some of the information. So I really like to rerun those builds on command line to see more output and to really know that the problem lays in Gradle, because sometimes it can happen that Android Studio just fails at some points. So for example, whenever you run a build and it fails, you could use the -s modifier to instruct Gradle to print the entire stack trace of the failure. So if there's an exception during the build, it will just, but like by default, it will just tell you what the exception was. So just the name, the message. But if you want the stack trace, you would just use this modifier to see the complete stack trace. Also, you can modify the amount of log output you get on your command line. So default one, the stuff that you see when you just run the builds without the modifiers is called normal. So there's one called info. Info will just give you some more output from all the parts of the build, which is quite useful when you're debugging some issues with your build. There's the debug log level, which is, you could also use it, but it's quite verbose. So it's just all the information that gets printed into the log output. But again, if you're debugging some problems, then this might prove useful. Another good modifier that I usually use is the -- offline. So this tells Gradle to run your build in so-called offline mode. So it will not try, for example, to resolve any dependencies, so to connect to any repositories to download dependencies. It will just rely on the local cache. It will, of course, be faster because it doesn't do any networking, but the build will fail if you don't have any dependencies in the local cache. Sometimes it makes sense to speed up the builds that you do. Somewhat like another side of it could be refresh dependencies. So we're using this on our CI environments just to make sure that all the dependencies are up to date. So what this modifier will do, it will not actually just re-download all the stuff, but it will check with the repositories if the dependencies are up to date. Because the way it works, so with each dependency, your local cache has like a hash that represents this dependency. And it will just try to verify this hash against the repository to see that it's like actual artifact that the build is using. So refresh dependencies will just check all this stuff once again to make sure that the dependencies are up to date. Sometimes a question arises, you know that there's some odd dependency in your build, and you don't know where does it come from, probably some transitive stuff that gives you problems. An easy way to know is to use the dependencies task or the Android dependencies task. So those print out the actual dependencies of your project. For Android dependencies, those are just Android related. So the SDK and the support libraries, all that stuff. So how the output looks, it's like an ASCII graph, nice one. So as you can see, this is like a list of all the stuff that gets packaged into your final APK. So it just lists all the transitive dependencies. It also has some interesting details, like you see the arrows in there. So what that means, like for OKHTTP, this means that retrofit is relying on OKHTTP of version 3.3.0. But because at some point we declared a higher version of OKHTTP, then the resulting one that will end up in our final build is the higher version. This is how the dependency resolution works by default. So it will always prefer the higher version of a dependency, even though like another artifact transitively depends on an older version. This is something to keep in mind. You can also see those stars, so I was quite curious what do those mean, and it wasn't too straightforward to Google that, but I found it on just so that you know it will just, so if you see a star, it means that like this part of ASCII graph already appeared at some point in the output before, so it just omits the duplications, just to note. Another quite useful task is called dependency insight. So in case you want to investigate where a certain dependency comes from, what version is used, you can use this task. So you give it the configuration that you want to check against. Normally it will be compiled. The dependency, you could just use the name of the module. In this case, this is OKHTTP. And you will see another ASCII graph, which shows you quite clear where OKHTTP appears in your build. And you can see the line which is called conflict resolution. So this is like the artifact that will actually be taken by Gradle, so the one that will be preferred. It's also quite useful. All right. Yep. So that's another quite useful thing to investigate the dependencies and where they come from. So another good advice, cool feature that I'm using quite frequent. It's called the build config fields. I guess some of you have used it already. So this is basically a way to declare some parameters in your build files that you can later reference in your Java code. So basically, when the build happens, the Gradle will create a Java file called build config for you, and all the fields that you declare here, they will be available through Java code. So one of the applications is to change some values to substitute them between your build types. So for example, like this one here. Say you developed a feature that will allow your app to update some value from the server once per 24 hours. And then you give it to your QA guy, and he says, okay, should I wait 24 hours to check that it works? Of course, that's not ideal. You can do better. You could just replace it in some test builds variant. You could just replace it with a smaller value. And those will, so at the time of the builds, it will just pick up the right value for the build type. Another quite cool application is storing some sensitive values. So you know, the API keys or some app secrets. This is stuff that you shouldn't put it under version control and keep it in your Java files. This is just best practice. The way around this might be to add it to the Gradle properties as the key value pair. So you can see that in this example, this is the Gradle properties that lives on your development machine. So it's under home directory, .gradle folder, and Gradle properties file. So this is not the Gradle properties file that you store in your project. But Gradle still can see this one. So then you declare a build config field, just give it a name. And you can also reference this key value pair from here. And then you could reference this build config field from your Java code. So in this case, this will depend on some value that just lives on your development machine, so you don't have to publish it to anybody. So just keep it safe. Another cool tip that I just discovered quite recently. So imagine a situation where you're using, say, support library, and they have lots of localized resources, such as translations for strings for different languages, but your app only supports, like, say, English and German. So in order to avoid the situation where the user would, say, a French locale on a device, seeing some French translations on the strings that you don't expect them to see, basically localized versions of them, you could just instruct Gradle to strip all the localized resources except the ones that your app actually supports. So you can do it with res configs. That's quite a good thing to use. And I guess the last one, I borrowed it from Dan Liu's article. So he suggested quite a good way to share the code between your test source sets. So you know, in Android, basically unit tests and Android tests, they live in different source sets and they don't have access to each other. But it can be that you want to share some code between those, say some mocks or whatever example. So it's easy to create a folder and add it to the source sets of both test and Android test. And then those classes will be available for both source sets, and you could share code between them. And of course, just consult the documentation whenever you want, just posting that links to the Gradle build language reference, quite a lot of resources on how Gradle works, the internal classes of Gradle. Gradle user guide is probably the best resource on most of the topics for Gradle. This one, so many people say that this one becomes obsolete quite quick, which means that Gradle evolves quite fast, but still on some core topics you will find probably best explanation in here. The Android DSL reference, also what's related to the Android Gradle plugin. And yeah, I guess that's it. Thanks a lot for coming, for your attention. I really want to thank my employer, One-on-One, for supporting me at this conference. And yeah, if you have any questions or you want to contact me, then please feel free.